All right, let's put this candidates test to the test. Yeah. So first things first, we need critical values, endpoints. We should verify that we have the conditions met to even consider the extreme value theorem. We can see for A, we've got a quadratic, which is great. In fact, we could even use the fact that it's quadratic and to help ourselves a lot. But quadratics are continuous, and we have our closed interval over here, 0 to 3. So feeling very good. We've got the EVT on our back on our side here. I'm going to go ahead and just run through the candidates test, then we'll discuss if we could have done this a little bit more cleverly. Uh, f prime of x, well, that's 4x minus 8, which means we have one critical value. That critical value is 2. And we'll verify that critical value is in that closed interval. Perfection. So now we have our candidates. We want to make a table. It doesn't have to be a table, but a table is a nice way to organize, of all of our candidates. 0, 2, and 3. So we have a candidate that happens to be our critical value for this case. We have 2 that are the endpoints. Now, thinking cleverly, I know that critical value for this particular function is also going to be the x coordinate of my vertex. And this is a parabola that opens upward. So I'm just sort of like thinking right now. I can add more nuance to this graph in a second. My vertex is at 2, positive 2. And I'm going to be growing right up and up. I could already tell you, just kind of thinking about this graph, I'm not going to go far. If I'm stopping at 3 versus 0, this end up higher, right? Because I've gone further off to the side. So I'm already thinking max and min. Now, of course, I need to know their values anyways to write out my answer. So all of this cleverness is not really helping me in any way. It's just because I want to do it. So then let's go ahead and find our f of x's, our actual values. This is how we're supposed to use our candidates test. So we're going to plug these numbers into the original function, right, to the OG function. Only thing f prime did was get me a critical value. Now I need to plug into the original to see exactly where they were on my graph that I sketched poorly because I didn't really care about where this graph was. All right, so if I plug in 0, this is at pop 1. Let me go ahead and make my graph a little bit. So 0, 1. Cool. Now I'm going to plug in 2. Well, let me think about what happens at 2. I have to do a little bit more work now because, yeah, I do. I'm going to have 2 times 2 squared. That's going to be 8 minus 16 plus 1, negative 7. Okay. 1, 2, 3, 4, 5, 6, 7. Right. 1, 2. Cool. See, my sketch was horrid, but there we are. Cool. Cool. Okay, and now let's go ahead and plug in 3. 3 would be 2 times 9 would be 18 minus 24 plus 1. So negative 6 plus 1 is a negative 5. So there's my last one. Boop. Which is exactly what I expected because I knew some stuff about this graph. We have our parabola, which will of course be symmetric because that's why we have an axis of symmetry. And we went further to the left, so we have our maximum value. In fact, let me go ahead and write out our final answer. The absolute maximum is 1 at x is equal to 0, and the absolute minimum is negative 7 at x is equal to 2. So we can see that by just looking, okay, what's the smallest number? What's the biggest number from our candidates? If you don't have every candidate, you haven't really shown enough communication to prove this. Like I said, what I talked about that truncated parabola is actually going to be harder to mathematically communicate than just plugging in numbers and being like, well, 1 is bigger. That's way simpler to communicate than like all of the thought that went into what I said previously, right? You're not making a video, you're writing it out. And so in some ways, just having a table of values is probably your simplest bet. All right. Yeah, let's stop that and we'll do B in a separate video.